All right, good morning and welcome to the System X x86 Virtual User Group for September. Today we welcome Corey Morris from Intel to talk about the overview and update of Intel products. I'd like to remind everybody that the call is being recorded for later playback, and therefore we've muted all the lines to not have any kind of feedback. And there will be questions and answers at the end of the call. Please utilize the chat window on the side panel, the WebEx side panel, in order to ask questions. And then again, we'll review those at the end of the call. With that, I'd like to go ahead and pass it over to Corey. Thank you, Corey.
Well, thank you. Thanks for having me today. And thanks, everyone, for joining. Today, I'm going to go over an update of where Intel is today with Xeon processors and products, particularly around Lenovo, and then talk about Intel SSEs and NICs. Without further ado, I'll start out with, and I'm trying to paint a picture of the holistic view of Intel. We have a development cycle called a tick-tock development cycle where we introduce a die shrink or a process technology shrink, and then we also have another phase on the top where we introduce a new microarchitecture. And right now, we've introduced a new microarchitecture called Haswell, highlighted there on the screen. And this is a 22-nanometer process followed over from Ivy Bridge. With this new microarchitecture, you'll get bigger improvements on a TOC than you actually would on a TIC. So moving forward, you'll see that we have a 14-nanometer, 10-nanometer, and so on going forward. And we'll kind of break down into these moving forward. So where I'm going to start with the Xeon processor lineup, we'll start at the top and then work our way down. So E7, the E5, and so on. And for today, I'm going to talk primarily E7 and E5. This is a public data center group roadmap for 2015 and the future. And starting with the second line down, more or less, probably following my cursor here, the Intel Xeon processor E7, 8800, 4800, and 2800. And the way we number these things are the first letter is the wayness or the sockets, and then the actual SKU follows that behind it. So this one says V2 when it's actually V3. This was an image, I couldn't quite change it, and it's blessed for public, so I had to leave it. But we are on V3 on the E7 right now, and then going down to the EP, which is our 80% of our business, is the E5 product line. We have a single socket 1600, we have a two socket 2600, and we have a four socket 4600, all on V3 at this very moment. And we'll talk more about how that lines up with the products here coming up. So we have our E7, E5, E3. That is our main cadence as far as processors go. E5, E7 are bread and butter server processors for heavy compute and high performance computing, along with the Intel Xeon Phi coprocessor on the right side that is highly designed for 100 threads or more, or highly parallelized code. For example, life sciences, if somebody was calculating the coefficient of waves crashing on a jetty, you could take that Phi with the 61-core part, offload your workloads from the original Xeon E5 or E7, and finish that computation from like 3 days down to 4 hours. And that's the whole idea behind Xeon Phi as a coprocessor, is to offload highly parallelized code. What I've done is put Lenovo servers around the product names so that you can kind of associate some of the ones you might be using today that have the capability of E7 and E5 on the left here, E3 on the bottom, and then the Xeon Phi on the right side. Now the E3 is unique. It follows the cadence of desktop processors. So the E3 is always one generation ahead of the E5 and E7. So if you're ever looking to develop on the newer technology or newer architecture and get ready for the E5 or E7, it's always a good idea to get your hands on an E3, which gives you that early preview before you go into E5, E7. Breaking down even further, I'm not sure a lot of folks fully understand the main cadence difference between E5 and E7, so I'm going to give you the highlights in a real quick form. So E7 is our mission critical, always on, always up, top of the line processor. This one, its main bread and butter is the 4-socket. And we have the big difference between the 4-socket E7 and the 4-socket E5 is the middle cross in the middle, the quick path interconnect and that allows for 1 hop per processor on an 8 or 4 socket, and even an 8 socket config is still 1 hop in the main 4 cores or 4 procs. The E5 4 socket down below you see is more like a token ring bus, right? The E7 supports 2 sockets, 4 sockets, and 8 sockets. So does the E5, single socket, 2 socket, 4 socket. And the E3 is mainly for single socket purposes for workstations and high-end desktops. So the E7, another huge difference is its memory footprint. So if you have a high dependency on memory and you need 2x the memory performance or memory density on a server, the E7 is the right choice. It can do 2x the memory load up on and without having to bust what we call penalties for loading up all the channels. So I would highly suggest the E7 for anybody that wants a very large memory footprint and just don't load up that last channel to maintain your higher bus speed on the memory. And lastly, the E7 has the top-of-the-line RAS features, about 75% more than the E5 will, and it's more designed for virtualization, HPC, and critical workloads. We're going to get a highlight of the E7 today, the V3, and again, the weightiness is the 8,000 is 8 socket, 4,000 is 4 socket, 2,000 is 2 socket. And we didn't list the 2,000 here, 2,800, but it does go all the way down. The big key difference here is the cores have increased, and we'll talk more about that in a sec. 20% more cores on the E7 year over year. It does have a unique feature on the memory. It's the only one that supports this. We're moving the DDR4 for V3 period. E5 only supports DDR4, but the E7 supports both DDR4 and DDR3. You get huge power savings moving the DDR4, speed increase, power savings, and so on. But a lot of folks on the E7 line would rather be able to support DDR3 as well. And here's that third QPI bus coming off that corner. Allows you to have that great 4-socket advantage on the E7. A side-by-side comparison shows we went from 15 cores to 18 cores on the maximum SKU part. Each core has 2.5 megs of cache associated with it. So as you grow in cores, you grow in the last level cache, or the L3 cache. So even if you were to fuse off cores, this is a common question. So if you take cores away, or you say, hey, I want to use half the cores on the processor, all the cache is always available to you. So you can even go down to 1 core if you wanted to and still have 45 megs of L3 cache. All right, so it's a common question, comes up quite a bit. You'll see memory density is still the same, even though it supports DDR4 now. And the max speeds have increased to 1866, slightly slower than the E5. The I/O bandwidth, PCI Gen 3 lanes are still 32. Quick Path Interconnect got upgraded to 9.6 gigatransfers per second, and a whole slug of new RAS features, which we'll dive into some here in a little bit. Trying to show a view of our SKUs, and I talk about these all day long, so it's pretty easy for me to rattle off SKU numbers and then associate them to workloads and which ones are best for which purpose. We have a basic, standard, and advanced, or good, better, best philosophy, where the basic is more of an entry level. Even on an E7, we have 1 entry level processor. The basic usually comes with no hyperthreading or no turbo boost. So the standard and advanced have those features built into them and are more scalable per se, especially with licensing models. There were a lot of SKUs on the left, so we simplified most of those E7 SKUs on the right side to a lot simpler stack. The main takeaway from this slide is no matter what the weightiness says on the processor, name, like the 8,000, 4,000, you can use the 8890 in a 2-socket scenario. You can use it in a 4-socket scenario, and so on. So don't let the naming schema think you have to use them on an 8-socket setup. All right, I know we're going to have questions at the end of the presentation, so I'm looking forward to that. And then we're going to jump into the E5, or what we call the EP. So the E7 was the expandable line, so they call it EX. And then this one is the performance line, and it's EP. And this is the V3 as well. So We're looking at a core increase as well. We'll hit that up here in the next slide. Some of the new features is new instructions for AVX or floating point. Introduced a DDR4 as we talked about, but the speeds here on E5 are 2133. We have new support for core P states, independent uncore frequency control. So what that means is in the past you had to control all your cores relatively the same. They weren't independent, and now you can say, hey, I want this core to have its own unique power state on all the different cores you can control, and each one can be uniquely frequency control on each core. And that gives you a lot of flexibility when it comes to virtualization. And the chipset is a C610 series chipset, same as the previous. No change in the PCI Gen 3, 40 lanes per socket. DDR4, like I said, and only 2 QPI buses. So looking at the highlights, you have up to 18 cores on the Haswell E5. The actual power TDP went up to 145 watts, and then for the workstation, WS is 160 watts, and they used to be 5 watts lower on each. Some of that's about the regulation of the P state. The socket is the R3, still 2011 pin. That's a 2-socket scenario here on this particular model we're looking at. They have DDR4 support up to 2133, 1 DIMM per channel, or 1866, 2 DIMM per channels. And the RDIMMs are supported, load reduced DIMMs are also supported. And then the QPI bus also 9.6 gigatransfer per second. I'm trying not to put you to sleep with these reading the foils. There are, back down on the board on the LOM, you get 10 gig and 40 gig standard gigabit for Ethernet. We'll talk more about the networking here in a little bit. So this is the E5 2600 V3 product stack. This is not a very common slide shared with many people. So it's a very important slide, however, to show the actual variety of E5 and why it's our 80-20 as far as processors. So looking at the left, you got that basic standard and advanced, just like the E7. And you'll see that in the standard and advanced, you got the turbo boost and the hyperthreading. So what the turbo boost does is allows the processor, given the thermals are low and their cores are not all being used, it'll look at the workload and it'll boost your maximum, usually almost 1 gig ahead of what it's set at. So if it's 2.4 in this case, it'll boost to 3.3. It'll do that as long as the thermals are not hit. So if it reaches its thermal capacity, it'll start scaling back. And that's how turbo boost is ran. It's OS independent and it's controlled by the processor. You can turn that on and off, it will. By default, it is enabled. Intel hyperthreading allows you to have double the cores. So if you turn on hyperthreading and you have software that takes advantage of hyperthreading, if you maximize all, let's say, 8 cores in this scenario in the standard, you would then look like you have a 16-core part to the actual software and with hyperthreading enabled. And then as you go up the stack, your cache gets higher because the core count gets higher. Right? Now on the right side, this is the important part. Right in the middle is frequency optimized. What we've done is taken the basic standard and advanced on the left, and we fused off 2 cores from each of the families, and the lower one we did 2. And so instead of having a 10-core part on the top here, 3.2 gigahertz, we fused off and made it 8 cores. The last level cache remained the same. All the features, even if it was basic or standard, are now all advanced. So you're getting a premium setting of advanced in all these SKUs. And these are like the engine is revved up. These are set up to be always on, high frequency. So if you have single-threaded applications, CAD design, something that needs to be in order processing, this is the best processor to pick because the frequencies are so high. And lastly, the segment optimized at the top. This is great for virtualized environments, people that want to have high core counts and ultimately the best performance. So if you're looking at the spec.org or integer or floating point performance benchmarks, you'll notice that the frequency optimized SKUs don't outperform the segment optimized. These are the highest performing parts on the top. But these by far are the best for single-threaded applications. And I think we'll get a copy of this whole slide deck out to all you guys after this. It shouldn't be a problem. I'm going to jump into the Xeon Phi and try to explain when is a good time to use this product. I don't know if everybody's familiar with this product, but its sometimes codenamed as Mini Integrated Cores. And right now, it is a product that you put alongside with your server. For example, if you bought a X3850 and you wanted to have Xeon Phi support, you could add up to, if it fits in the chassis, up to 4 of these in a server configuration, and sometimes all the way up to 8. So it depends on what you can fit. These are double width cards. I have a picture here in a couple slides. And what it looks like is a graphics card if you're a gamer. And it offloads the code. So if right now, if you had a single source and you compile with the Intel compiler, parallel compiler suite for the Xeon today does a great job of parallel computing. So it just doesn't have enough cores to do that mini stamp and go faster. So you write in your code to offload to the Xeon Phi, going up here on the top, and then it goes to the 61-core part, and it's greater than 50 cores, so we have a variety of different sizes. And then it allows it to just execute much, much faster on a highly parallelized workload. So what's that give you? So if you have a Xeon, you'd want to optimize it for Intel, the Intel compiler for Xeon period anyways. You would then be able to add in the Intel Phi card today, and then recompile your code again with the Intel parallel compute suite, and it'll then optimize your code to run on the Xeon Phi, and you'd have to tell the code when it needs to go to the Phi. Otherwise, you got a glorified heater in your machine. It will do nothing. So the code has to be reported. I wouldn't say ported. It has to be re-optimized with the compiler. It's the same x86 code that you've been using all along, and you just point it out to the Phi. So looking at some Xeon Phi coprocessor product lineup, again, the good, better, best family, the 3 family, 5 family, and 7 family, trying to keep it as easy as possible. Some of the lower cost units, if you ever wanted to test them, would be that 3 family. And you'll see a P for passive and an A for an active fan. So depending on how much power you have available in your server, pick the right SKU. And how much fan, how much airflow you have already set up, and your server will tell you if you need passive or active. So if you're looking at the bottom here, 6 gigabytes DDR5, 240 gigs per second, 1 teraflop, double precision, and 300 watt total power. So as you move up the stack, you'll see that one will have more memory, one will perform better. You can see it goes from 6 gig to 8 gig to 16 gigabytes. The top of the line 7120 is a product that most folks will pick if the 61-core part for highly parallelized, getting the work done faster. Now we are moving to a socketable form, so you'll stop seeing these products so much. They'll still be available, but you'll also be able to say, okay, I have a 2-socket Xeon. I'm going to pull one of the Xeons out, and I'm going to drop in a Xeon Phi coprocessor socketable one, and you'll get phenomenal better performance because now we're not relying on the PCI Gen 3 bus with the 1,000. The transfer rate is much slower than the actual socketable form at the QPI. Trying to keep it high level. All right, it's feeling different when I don't get any feedback, so I'm just going to keep going. And at the end, George will be next after me, and then we'll have questions. All right, so I'm going to cover SSDs and NICs next. And Intel solid-state drives solutions, we have basically 3 categories. I'm looking at the time here, doing a timestamp. Perfect. We have data center family. We have professional family and consumer. So we're going to focus on data center today, but professional family would be more like enterprise clients, Opal support, things like that. And consumer has some enthusiast drives that are NVMe even. There's NVMe in the professional line, and then definitely NVMe as their new host controller going into the future here with the PCI interface. So where Lenovo focused a lot of their time currently is the data center drive P for PCI 3700 and 3600. And the way we built these drives on the PCIe is the P3500 is a great drive for read. So it's designed more for being read from. And it has 400 gigabytes, 1.2 terabytes, and 2 terabytes. You can see the sizes variety here. The P3600 is our 50/50. It's good for write and read. And the P3700 is entirely designed, but can be used for all of them for writing. So it's a high endurance tested drive. And you can do 10 full drive writes per day. That's the whole drive. And it'll last 5 years, 10 years down the road. This thing is highly designed, has a lot of overhead, primarily for writing to flash. Now on the SATA side, it starts with the S. They support the 3710 and 3510. And these just have your typical SATA interface. You can put the SATA to SAS headers on them if you want to use them in a SAS scenario. And these are great drives. The IOPS are usually half of what or even a lot less than the PCI-based devices, just based on the device structure and the bus speeds. I know you guys are all familiar with the difference between SATA and PCI, or NVMe. So one thing I really wanted to hit today was some of the new technology called 3D X-Point or Cross-Point, as Intel would say, technology. They also have another brand that goes along with it called Intel Optane technology. It's pretty much hand in hand here. And what we've done is taken the Intel NAND, which is today all MLC or multi-level cell NAND. A lot of folks have single-level cell. Single-level cell only goes so deep in density. Single-level cell is by far the best, the fastest. It can last a long time, but it just can't scale in capacity. So everybody with a multi-level cell, Intel put their standardized around MLC, and other competitors who tri-level cell and so on. So right now, we have our NAND drives, as what you're seeing, what I just read to you. All those are based on NAND technology. And what we wanted to do is come up with some new technology, and we've worked with Micron and Intel came together and came up with this new 3D X-Point or Cross-Point technology. So it takes the benefit of DRAM, the ultra-high speed of DRAM. It took the great low cost of NAND and made it volatile, so non-volatile. So you don't have to worry about the power being dropped off. Your data is still stored. So it really doesn't fit in NAND or DRAM. It's a brand new technology. There is no classification for it. When it first came out, I was like, it's got to be PCM. It's got to be NAND or DRAM. It has to have some kind of category like phase change memory, but it doesn't. It's an entirely new architecture, a new idea, and it's going to be greatly change the way we look at flash and storage today. So the way it works is they took a whole new high-density design, and they made this structure stackable. But the selectors are more based on not phase change, but more like a block sector where they look at the block. And this is a transistorless technology. So there is no transistors in this memory. It's all high endurance, non-volatile, it's stackable, and you can get 8 to 10x the density of what DRAM offers, but at the same time, the very fast speed of DRAM and the lower cost of NAND. So this is something just to keep your eye on. It'll probably hit next year. It's been announced and everything, and there's a whole product line coming out around it. And last but not least, it talks about, if you're looking at the left, and this is primarily the most important part, so DRAM, it talks about latencies in nanoseconds. We're looking at NAND, it's in microseconds, and then hard drive, spinning disks, are milliseconds. So looking at 3D Cross-Point or X-Point, you're in the speed of nanoseconds with the lower cost of NAND today and so on. The performance charts, everybody's claiming are off the chart, and just keep your eyes open for this. All right, we're going to jump into Ethernet controllers, and we'll all wrap up and then hand it over to George. So Ethernet converged networking adapter family is pretty big. I don't know if everybody knows all the different adapters Intel offers with Lenovo, but there's a slug of them. The only one I didn't cover is the 1 gigabit Ethernet, the 350. I just left it off the chart. So I'm going to hit the 10 gigabit and the the 40 gig cards, and they kind of talk about the X and the XL710 family, and primarily focus on the new one. Now, the folks know that some of the nomenclature here is like the DA1, the 1 signifies the 1 connector, and the 2 is the 2 connector, and the DA4 would have 4 connectors. So just associating some of the naming that Intel picks so you can kind of familiarize yourself. The XL710 family was entirely designed around the future of the data centers of the future, meaning that they're software-defined networking, virtualized networking, anything to do with virtualizing the entire data center. This card was centered around that. So look at this card as the future change for Intel's NIC. I left some slides on here to kind of illustrate that we're going for a completely flexible and more efficient Ethernet NIC for people can easily adapt and connect and use the new 10 gigabit Ethernet or even the 40 gig card that we offer. And there's some brand new technologies as far as the cabling, the ease of cabling, and going to that software-defined networking structure. Some of the important parts that people don't realize is the power efficiency improvements from even the X520 family that's been so popular with the 2 by 10 gigabit that had 5.8 watts of total power. The move into the XL710 would replace that card would be a 40 gig port running at 3.4 watts. So it's half the power and 2x the bandwidth as far as performance goes. And then mapping up the right technology is important. So I thought I'd show this slide to kind of illustrate it's really about how you couple and design your server is what you're really going to get for performance. You can go out and buy the best NIC card ever, but if you kind of not line up the storage correctly or the processing power, you can not get the performance that you were expecting. So in this example, a 100 gigabyte file calculated for transfer times, you can see on the right, on the bottom was a spinning disk plus the i350 T2 card, gave you about 15 minutes for a 1 gig connection. And moving up the stack, they tested a solid state NAND flash memory, the S3500 SATA interface, and with an X710, and it got down to a minute at 10 gigabits, and then so on. You can see that going out to 22 seconds using the P3700, which is a PCI-based drive, with the XL710, which is the 40 gig. So all the way down to 22 seconds in transfer time from 15 minutes. Pretty good. Last but not least, I left the reference charts. This is, I know, a lot to read. I'm not going to try to cover it, but it just shows what Lenovo servers are in the offerings. You probably know a lot of this already, but I left this as a reference, and it shows the part numbers that are associated to each, if that helps. And my last slide here, I'll just talk about how Intel, if you're looking at the E7 and the E5 product families today, the great combination is not just a processor, but with the storage media today, with SSDs, and moving into the new Ethernet converged network family of the XL710 with the 40 gigabit Ethernet. The whole combination just works really well together, and that's it. So thank you for your time, and I'll be around for questions after George speaks. And anything, we're always here to help. My actual background is a double E here at Intel. I've been here 20 years, and I cover all the products in data center, and I'm more than happy to assist anybody with their Lenovo server designs or workloads or benchmarking or anything like that. So thank you for having me today. So George, are you on? I'll go ahead and turn it over to you.
I am.
All right.
All right. Thank you so much, and appreciate all that. That was amazing. And let's see. I want to share. I guess I'll just share out my monitor, and we'll just kind of walk through my slides. So let's see if I can just jump in here. Hi, everybody. My name is George Clement. I work in the Data Center Management Group, basically to help, and I work with I help customers, specifically partners like Lenovo, utilize and leverage the sensor and telemetry data. Something was mentioned previously, but basically we use that information to help our vendors, our customers, particularly Lenovo in this case, build better software to help customers, to help their customers assess data center management, do better planning around capacity management inside the data center space, business continuity planning, do a further deep dive into the telemetry data and what it's showing you about how effectively your customers are heating or cooling their data center environments, and how much power consumption are they actually utilizing inside of those racks of sets of systems. So today I'm going to talk to you about basically the Think Server Energy Manager. It is going to be soon called the X-Clarity product or X-Clarity Power Manager. It will be, in its current form, it is currently released as a Lenovo product. So I work directly with the Lenovo software engineers as well as other people on my team, obviously, to basically get this software in place and in the customer's hands. And then I help support, basically, or work with you guys in respect to the field and the other areas, other people outside of Lenovo who are interested in the product and utilizing it with the server hardware. So if you can see me, if you see my screen, basically we have a couple of things here that I want to kind of cover really quickly. Basically the Think Energy Manager or Think Server TSM product comes in a couple of different SKUs and in different ways you can actually purchase it.
George,
the
quick,
capability, yeah.
George, real quick, let me have you, if you could maximize your screen, it'd be easier for us to see.
Oh yeah, sure. Thank you. Sorry about that. Let me see
if
I can map this slide. So.
Sorry to interrupt your flow there.
No. I need all the help sometimes. So the Think Server TSM basically comes in a couple different products, if you will, or the software comes in a couple different flavors. The premium includes like basically a few extra elements, right? Virtual KVM capability, virtual media capability, and also our software, which is the Think Server Energy Manager software. So when you buy TSM Premium with the new Grantley product line, or when your customers do, this basically can come along with it and be supported and be downloaded and installed and be supported automatically. You can also purchase it for the System X, Xeon E5s, etc. So the M5. Those products basically can also be supported. There is a licensing structure for supporting the System X systems, and we do support other hardware as well through Think Server Manager. So if your customers or you currently have the System X systems as well as some Lenovo systems and potentially others, this product will cover all of them, or cover the a good bit of those particular hardware platforms. So don't think this is just solely a Lenovo product or a Lenovo capability. This software offered by Lenovo basically goes across various different SKUs. And what it will do is basically go in, be installed in the data center space and start monitoring those systems and collecting up power and thermal information for those systems. So if you have thermal issues in the data center space, or you have you're concerned about power or even constrained power in respect to basically, I think I've under-provisioned systems into this rack, this hardware will help you plan for better. And I'll go into more detail about that in just a minute. So what does it do? Basically, it is a product that offers a dashboard as well as further analytical elements to and its focus is obviously looking at the individual server hardware, going in and accessing that information through the node manager port or other BMC capabilities, so baseboard management controller. You may know that as basically like the IMM interface or the Dell iDRAC interface or the HP ILO interface or the node manager interface. It'll access that information access the server telemetry data through that interface, and then basically use that data in mass in a data center or in a room or in a row or in a rack, assessing the power consumption and the thermal data to identify where we have lower underutilized systems, where we have appropriate energy consumption, where we have appropriate thermals, and if not, basically it'll provide suggestions on what to do in respect to those things. So a few little pieces. Basically, it does support up to 1,000 systems at the moment per instance. That is a smaller limitation. It's not necessarily a physical limitation. It's more of a soft limitation in respect to the hardware. So it can support much larger implementations, but it's generally what's on the box. It provides the power management elements, and it basically continually monitors the systems, providing real-time information as well as historical data on power consumption and thermals, so that the data center becomes clear as far as how effectively it's actually servicing its hardware or the servers within it. This is useful because basically we spend a lot of money, or people spend a lot of money on OpEx in respect to basically maintaining those data center spaces. So this software helps people assess how effectively they're spending that money, whether they're overcooling or undercooling in particular areas, or basically expecting a certain amount of power and utilizing a difference, so that they can actually assess whether they can put more racks into that particular room or not. It also encompasses alerting capability. So you can set up thermal alerts, power consumption alerts, and it can monitor and alert basically via email or SNMP track forwarding to higher end consoles. So it provides a user interface as well as interfaces with the more enterprise savvy or more enterprise capable devices. And so I want to provide a little bit of a demo here as possible. Hopefully I can just pop into my UI, and if it's here, hang on a second. Where is it? Hang on one moment. Pause that. Stop. And go to there. And I'm going to go to, why did it close it? Hang on one second. Lenovo. Perfect. Zoom. There we go. So hopefully you can see my screen. This is the console itself. This is just a demo environment with a couple of rooms and hardware. Excellent, thank you. So this is like the top down or the console UI. This is the front end of the UI. This is basically your main console for your operations folks. It's customizable. It contains several widgets that basically gives you space capacity, temperature trending for the entire day, temperature data that it's picking up from the individual systems, identifying hotspots in the room, and allowing you to zero in on those particular servers or devices and get real-time power and thermal data for those particular devices. So in the sense of basically providing, it goes in through the out-of-band information. It basically goes directly into the interface, the baseboard management controller, not through the operating system, so no agents are deployed to the applications, and allows you to basically collect this real-time telemetry data and provide it in mass. So like you can get it for a rack or an individual system or a row, et cetera. So you can see basically how much power you're consuming versus what you thought you would be consuming. What are the temperatures? What are the average temperatures for the systems and the racks and the rows and so forth. So this is basically the dashboard is the heads-up display. The second level, basically a physical ability to drill down into the data center, the rooms, the rows, and the racks are right here. The temperature information, basically the historical information that you have for both basically for up to a year is stored in this particular tab. It's exportable as well. And it also supports various things like I mentioned, alerting, like thresholds, as well as implementing power policies for sets of systems as well as individual systems. We heard a little bit about how you can change the frequency settings on particular cores and stuff like that. So this is basically an opportunity to be able to set power policies that prevent maybe significant overconsumption of a particular area, maybe where there's power constraints. So what you have here is basically a capability that admin rights only allow, so there's various rights inside the user interface, and admin rights only allow you to basically set up these policies, and those policies can help prevent power overconsumption to the point where you have an outage. And the ability to do that is basically all controlled by you or your operator, or your administrator, I should say, and or your customer that basically has, can help, can take the historical information and assess what's super overconsumption and what would be an issue or what would be the outage power consumption level. So I digress a little bit, but basically what the idea here is that we provide the real-time data, we do roll-up, and we allow you to zero in on a particular device or a particular grouping, that being a rack or a row of servers, and also the logical grouping. So if you want to set up a series of systems for basically further analysis, you can set up these logical groupings as well. So like you can have your email servers in one group or your accounting servers and so forth. People use this for various things like potentially chargeback or look back, where they can measure the power consumption for a grouping of systems that may not be in the same rack or same physical location, but they got to collect the data up and make it more useful to understand how much consumption these systems are going, what are the average temperatures for those devices, et cetera. And then basically, you know, what's the historical information on those particular devices as well. Let's pop out of that. So, like I said, this is a Lenovo product. It also provides further analysis on these using this telemetry data, right? We have the cooling analysis. We have the low and underutilized servers. We have basically server power characteristics, workload placement, and advanced power modeling. We're taking all of this information that we're getting, right? All the sensor telemetry data that we're pulling in from these servers, directly talking to the hardware. We know basically we've set up the data center rooms, the rows, the racks, et cetera. So we know basically how the physical location has been set up in the room. And then basically with the systems providing the data, you can then make sure that you can then assess basically how well or effective you're actually cooling that particular data center space. What's the variation in temperature range for the particular room? And are there basically outliers? As you can see, basically most of the rooms are really cold. Some of the room is actually pretty dead on where you want it. And then there's some outliers here that are basically higher temperature systems. So that could be like your hot spots. And, you know, that would prevent you from basically going in and fixing or addressing that particular issue. You know, the idea here is you want to address those hot spots primarily because if you do, you can then raise the temperature in the room potentially and then save money on your OpEx without actually, you know, without interfering with your the performance of your systems. So some of the things that we have here, like cooling analysis, like low and underutilized servers, where it'll identify those systems that are operating very low on their power consumption scale, and showing you those and using that as kind of a loose analog for maybe potentially looking at, you know, provisioning more workload to those systems. Because if they're not consuming a lot of power, most likely it's a good opportunity to look at them and see if they're doing any useful work or doing valuable work for you, and potentially provisioning more workload to them. Server power characteristics breaks down the actual devices by device and will basically by model and give you a range of actually power consumption for those devices. So that helps with refresh or assessing basically the power consumption from one model to another, so that you can kind of see how much you're improving your performance as well as saving yourself some money on the power. Workload placement with the new Grantley line. Basically, we get a really cool capability, right? We get CPU memory and disk I/O utilization data all out of band. So all outside of the operating system, we can collect that information directly. So what you can do is basically with the workload placement thing, if you have a workload that you potentially understand or think you kind of have a good feel for how much CPU utilization, how much memory and disk I/O you have, you can then basically put those numbers in, and it will take the current data and the historical information from the population of systems it's monitoring currently, and identify those systems that are potential opportunities where you could place more workload on, specifically the workload that you just categorized, or you just outlined here or described. So these are a set of systems that are potentially good targets for that particular workload, and that could take that workload currently. I'm just going to jump into a few more things, and then I'll be done. But basically, the idea here is that we basically have this discovery and import capability as well. The simple thing is, obviously, people don't want to add all these devices on their own, so we support an import capability as well as a discovery capability, and we support various different protocols. I mentioned IPMI because that's primarily the one you use for those out-of-band interfaces, right? So for your NIDRACs, your ILOs, your IMMs, your node manager interfaces. But we also support other network products or other capability, other IT devices that you'll find in the data center space. So we support those as well, as I mentioned. And we do that through SNMP, WSMAN, HTTPS, SSH, and then in-band protocols, which are your operating system type stuff like WMI and SSH. So these are really for your chassis capabilities. These are for more your PDUs, UPSs, et cetera. And this is really for your baseboard management control interfaces. But the idea is to support as many protocols as possible, as many devices as possible, and have them automatically discovered and appear here in your device and rack section. So once you do a network discovery across a particular protocol with some authentication credentials, you'll basically come up against, these devices will show up in the screen, and you'll be able to understand, okay, these are the types of models. This will all be pre-populated, and then like what its connection is, and then what it's capable of actually utilizing out of the devices. So like power monitoring, power control, only power monitoring, et cetera. All that information is highlighted here so that you can then use it for your own stuff. And it will, be monitored automatically and stuff. So I mentioned a few more pieces. User management, also in the Lenovo product. Basically, you can set up roles and groups, and it will also support Active Directory capability as well. So you're basically, your LDAP and your Active Directory capability is here and supported, and you can set up the groups accordingly, and then just, put them in, place them in there, and then give them particular rights. So we have the administrator roles and guest roles. And I mentioned there's difference in the two. Obviously, the guest is read-only. SNMP trap forwarding I mentioned there previously, and also email subscriptions. Remember, this is important for the alerting capability. So if you set up thermal alerts or power consumption alerts for a particular set of systems, where you want to know about hotspots or data center, issues, that will basically go to either your inbox or a operational console through that process. And then basically we have this emergency power reduction, this big yellow button, right? For administrators, basically if you have one of those scenarios where where you've walked into a room and it's significantly warmer than it should be, we have this product or this capability where we can actually select a particular targeted room and then target it for a power reduction, meaning bring down all the systems that we're currently monitoring in that particular room down to a lower power reading, a lower power consumption state. So basically this really reduces the performance of the systems, but it doesn't take them down all the way, which basically allows you to work on the issue, the thermal issue, and then basically bring them back up after you've resolved it. It sure beats the heck out of basically running around and turning systems off in that kind of a emergency type situation. This is an easier way for you to basically reduce the power consumption, thereby also reducing the thermal consumption, the thermals for the particular sets of systems, and then work on the particular outage or issue that you currently have, and then bring them up all through the user interface, or bring them back up, or remove the EPR, automatically or through the user interface as you go. Okay, so basically this is software. To sum up, this is the software that basically you get from Lenovo. This comes with the various SKUs. The premium includes it. And then basically we have a few more pieces here, but that's pretty much my wrap up, and I will go back into my main screen hopefully. So you can purchase it, you can receive the tokens, the download information is here, the URL string, and basically the process for actually getting the software is outlined here in this slide, as well as basically the SKUs for various different ways, and then the optional ways to actually get it, plus the prices are there. And then the links, basically the links for more information. This is a Lenovo product, so I've included all the links for the Lenovo capability, their details, and their administrative guides in here as well. And I think you guys will get the slides for this for sure, and if you don't, go pester me and I'll give them to you. That's about all I have, really. Ultimately, this is just we're just looking for a good opportunity to basically get this in somebody's hands or get this in people's hands so that they can start utilizing it. And it comes with the premium install for that, and it also supports the System X platform. And will merge more as basically Lenovo moves forward. Basically, it's going to be transformed into the X Clarity Energy Manager, and it will be further incorporating obviously support for more System X as we go forward. So I want to thank you for your time, and
Great.
that's it.
Thank you, George. Thank you. So yes, the slides will be available to anybody on our Wiki CoWork site. Link will be sent out via email within the next 24 hours. I guess, George, I'll start with you. A couple questions that came through. Do you have any idea if the Energy Manager will be tied in, or we're working on developing that to work with xClarity by chance?
Absolutely, we're doing. Basically, it's going to be renamed as xClarity Power Manager, so it will basically be the power management component or power management software for that rebranded as xClarity Power Manager.
Great, thank you. Do you know if the data within there can be accessible via scripts or CLI or anything like that?
Yeah, absolutely. We have there is a command line interface as well that's incorporated, as well as capability, basically an export capability as well. So yes, absolutely, it can be, and it's part of the user guide. Basically, I think it's like, I don't know, page 93, something like that. It starts on. But there's a command line tool for that, and yeah, we can talk about that offline.
All right, great. And Corey, are you still on?
Yes, I am.
All right, we had a question or two come in. Get to those. So Carl asks, what is the major differences between the enterprise and value SSDs? A number of times he's asked, what is just generally speaking, what is the major differences? Is it the number of writes to the drive or cost of manufacturing?
It is. So the drives are categorized, 3500, 3600, 3700, and basically it is about writes and high endurance testing. So the higher you go in the stack, the more it is write intensive, and the lower in the stack is more read. So the middle, the 3600, is the more read-write combo. So you're absolutely right. You pay more for more performance on the write.
Okay.
Okay. And that goes for both the SATA and the PCI. Good question, though.
Yeah. I guess that actually looks like that covers all the questions for you guys. Again, I want to thank you for your time. For everybody on the call has been recorded. I'll get an email out within the next 24 hours with links to both the slide decks. And George, if you could send me your latest, I don't believe I have it on the slide deck there.
Okay. Absolutely.
Next month, we're still looking for the guest speaker, I believe, for next month. So I'll get the invite within the next couple of weeks, or else actually it'll come from Kevin Conover. So Kevin Conover will be taking over as the host for the virtual user group, and that'll start next month. But again, look for that invite, and thanks to everybody for joining. Have a great rest of your day, and signing off.
Thank you for having me. All right.
Yes, absolutely.
Thank you. Thanks a lot. Bye-bye. Take care. Bye.